So now that we've learned about the molar ratio, we can apply it to solving some stoichiometry problems. And we're going to start with the simplest possible stoichiometry problem, which is converting from mole of one substance to a mole of another substance. So that's called the mole-to-mole stoichiometry. Okay, so the kind of problem that you would see looks like this. And in words, you would have to turn it into a reaction, a balanced equation. But in words, it would say how many moles of HCl or something are needed to react with 2.3 moles of zinc or something. And the first thing you would have to do if you got a problem like this is you would have to write an equation and balance it. So I've already done that for you. I've written the equation. It's a single replacement reaction, and it would be zinc plus HCl gives you hydrogen plus zinc chloride. So the first thing that you want to make sure that you do, like for any stoichiometry problem, is make sure that you have a chemical equation that's correctly balanced. Not only does it have to be balanced correctly, in order for it to be balanced correctly, it has to have the right subscripts. Okay, so you have to know what the formulas are, and then you can balance it. So I'm going to balance this for you, and you will see that even though I do not usually see a number in front here because it's a 1, I want you guys to realize that there is a 1 there, because when you do a molar ratio, you're going to have to understand that part of your molar ratio is going to be a 1. So having these molar ratios, and I didn't put 1s here because we're not even interested in these substances, having the moles here will allow us to get a molar ratio. So the next thing we do for this conversion is what we usually do for the conversions that we've done all along, and we use dimensional analysis. Okay, molar ratio will be part of that dimensional analysis, but we write down the given. So 2.3 moles of zinc is our given, and what we want to go to, our unknown, is moles of HCl. How many moles of HCl? Okay, so we set up our conversion chart. We have 2.3 moles of zinc. We need a molar ratio to go from zinc to HCl, so that we're going to go do the molar ratio between zinc and HCl. Which one goes on the bottom depends on which one has to cancel out the units of the given. So moles of zinc will be canceled out with moles of zinc, so moles of zinc will go on the bottom along with its number from the balanced equation. So 2 moles of HCl, that's what we want to keep, that's the unit we want to keep, and that goes along with its coefficient from the balanced equation. And then when we cancel out the units that we don't want, and we're left with units that we do want, we will be able to put this in our calculators, and this is very simple. So you'll be able to put this in the calculator and get an answer for 0.6 moles of HCl. So that's the simplest type of stoichiometry problem, but it's so logical and it's very convenient in a step-by-step procedure to do it this way that it will be useful for any type of stoichiometry problem that you do. So when I say any type of stoichiometry problem, I mean given anything, you will be able to find the unknown. Mole of one substance to mole of another substance, that's what we just did. Mass of one substance to the mass of another substance, we will do that next. And that just means you start off with grams and you end up with grams. And then you can go mole to mass or mass to mole, and even volume could go in there because it's part of your mole map. That's one of the places that you can go because you have a conversion factor for it. We won't do any of that right now though. So let's try a mass to mass stoichiometry problem. Again, in my problem will be my equation, and I will get a balanced equation. I'm using sodium as my given. Okay, I have 0.25 grams of sodium, and I throw it in a bucket of water. Okay, we've done this in class, or actually we've done it outside, and we've seen that you get this, this explosion. And during that explosion, we also make NaOH, because it's asking us how many grams of NaOH will be made. Okay, so we get NaOH and hydrogen gas. Okay, so balance reaction, I've already done that for you, so we're ready to use this equation and this balanced equation to do our stoichiometry problem. Okay, so as usual, 0.25 grams of sodium, that's our given. Using the molar mass of the given, okay, sodium. Using the molar mass of the given, convert the mass to moles, because remember that moles are the center of all chemistry, so no matter what stoichiometry we do, we have to go to a mole ratio, so we have to convert this substance to moles. We use the molar mass of sodium to do that, mole of sodium over 22.9 from the periodic table. Now that we're at moles of sodium, grams of sodium are gone. Our next, and if you wanted to do the calculation for this, you can actually figure out how many moles of sodium you had. You don't have to do this. We'll show you that the last thing. At this point, I have 1.087 times 10 to the minus 2 moles of sodium. Then I'm going to use that number, and I'm going to construct the molar ratio that we've been talking about. So I want to cancel out moles of sodium, so the moles of sodium is going to go on the bottom, so I can do that. And the moles of my unknown, which is NaOH, is going to go on top. They both happen to have the same coefficient, but that doesn't always happen. In fact, it rarely happens. And this will not change this value. Okay, but what it will do is change the unit of this. So now, because moles of Na are gone, my units are moles of NaOH. And then the last thing that we're going to do is, because we're at moles of NaOH and we want to get to grams of NaOH, then we have to use another molar mass. But this time, not of the given, we have to use the molar mass of the unknown to get grams. Okay, so now I have moles of NaOH, and I'm going to use the molar mass, which is 40 grams, adding sodium and oxygen and hydrogen molar masses. And when we cancel this out, you will get 0.43 grams of NaOH after you multiply this by this. And so I showed you a way where at each point we're calculating how much of this material we have. That is not necessary, and actually it's not even a good idea, because every time you do this, you're rounding some, you could be making a calculator error. What you really want to do, and still get the same answer, because it'll always be the same answer, is run this entire conversion, one right after the other, without stopping to do any calculations. Put your molar mass of the given first, then put the molar ratio, and then do the molar mass of the NaOH. And when you do that calculation, cancel everything out, run the numbers through the calculator, you will see that it is exactly the same number that you'd have gotten if you had done each calculation individually. So again, we did a very logical step-by-step procedure that allows you to convert mass of one substance to mass of any other substance in the equation.